Alright, so check this out. One of the things we wanted to do was I wanted to do another electron configuration. This time I'm going to do it for SB, which is right here. That's called antimony. SB called antimony. Excuse me, sorry. And why is it abbreviated SB if it's called antimony? It's because it used to be called, I think it's stibium, but they changed the name over to antimony. Same thing happened with iron, where it used to be called ferrium, but it got changed to iron. So first thing you want to do is take a look at the number, and I just covered up the number, so I apologize for that. Let's see. It's actually 51. SB is 51. I will just put 51. Alright, that means that there are 51 protons in here. For now, what we're doing is we are trying to figure out how many electrons. And for now, we're assuming that there are equal number of protons and electrons in here because it's a neutral atom. Alright, so if it falls into this category, this red category over here, it is in the S suborbital. Okay? If it falls into the purple category, it's in the P suborbital, and if it falls in the blue category, it's in the D suborbital. The orbital states, the first number that you want to come up with is actually just the row. And so here's the first row, the second row, the third row, the fourth row, the fifth row, the sixth row, and the seventh row. And same goes over here. The first one's up here. This is the second, third, fourth, fifth, sixth, and seventh row down here. One of the things I did tell you about is the D orbital. Suborbital, it actually goes down in energy state. So even though it looks like it's in the fourth row, it's actually, when you hit this column right here, it's 3, 4, 5, 6. And a similar thing happens when you're in this bottom area over here, and this area over here is called the F orbital. We'll make that one green, and we'll do a square around it. So that one's called the F orbital, suborbital, and that one is... Oh, oops. Oh, I did it in red. Whatever. That one actually goes down too. So it's supposed to go here, but it goes 4 and 5. So here's how you do the electron configuration for something hard like antimony. Alright, first thing you do is, well, I guess one of the best ways to do it would be to work your way backwards. So what you would do is you would say, okay, where is antimony? It's in the P shell. So I know it's going to have a P over here. Let's do it in black. P over here. And anytime you see an S, you think S can take up to 2 things. P's can take up to 6 different things. See, there's 1, 2, 3, 4, 5, 6 spaces for it to fill up. And there's only 1, 2 for the S to fill up. And for the D, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, in order to get all the way up to antimony, we had to fill up all of the stuff below it. So, here's how you do it. You go to the P category, because that's where antimony is. How many electrons are in there? Well, they filled up 1, 2, and 3. So, it's 3. And which row is that? That's 5. Cool. Now I'm just going to work my way backwards down the periodic table like that. And then down backwards this way. And backwards this way and this way until I get to my area, or the place I want to get. So let's see, 5P, this one right here is 4D10. This one right here goes back to 5S2, S2, and now I'm over here, 4P6, 3D10, 4S2, 2P6, 2S2, and 1S2. And that's how you do it. You just kind of work your way down backwards.